Tonight's meeting is about 160, the 160 meter contesting. And as I've already said now repeatedly, we'll have 3 presentations. My plan is that they'll be relatively short. So they'll be sort of 15 minutes or so each, after which we'll entertain 1 or 2 questions about that specific presentation. And then we'll go on to the next presentation. And that should allow us to sort of wrap up the presentations in 1 hour. And then we'll still have time, 20 or 30 minutes, for informal discussion and question and further observations. And this is kind of an experiment. This is the first time we've tried to do multiple presentations on one evening. I think it'll be fun because it'll bring different perspectives together. So let's get started. As I think all of you know, there is a long tradition of contesting, 160 meter contesting in Georgia in particular, in the Southeast, but in Georgia as well. And if you read the old bulletins from the Southeast DX Club, which I've now done a little bit of, you can see how serious they were about 160 meters, in the mid 90s. And I think well before then. We're very fortunate that 3 of the top current 160 meter contesters are with us tonight. And they're going to share some insights and tips for what they've been doing and what they are doing. And hopefully newcomers like myself can learn from. But we'll start with Charlie A4CF, who is I just looked it up. He's been in the top 3 at least in the ARL 160 meter contest from Georgia pretty much every year for the last 15 years. As I understand it, is doing most of that from a city lot. So we're going to start with him. He's going to give a general introduction to what he does, and then we'll go on to Jeff. All right, you're up, Charlie.
The first thing I wanted to show, though, what happened to that slide? There it is. So when I first came back to this QTH after living at a better one for a while back in the mid 2000s, and I was trying to put, this is a suburban lot that I'm on. So it's a subdivision lot. Okay. It backs up to the woods though, which I take advantage of some very tall pine trees back there. But I was telling somebody about what I was putting up and they said, great, Charlie, you can't keep a good man down. So, I always remembered the guy who told me that. And so, it's the challenge. And so technically what I'm doing for, a small lot, about the best thing I could figure out how to put up was an 80 meter vertical loop, because I want to be able to have something on 80 meters. And then, talking with some other ham radio friends, they said, well, if you'd push that against ground, it would probably work better for 160 meters than what I was trying to do before. So I did that. I ran radials wherever I could. A couple of the radials are maybe 10 feet, and then some of the radials are 140 feet. And then all the other ones are somewhere in between. He also said you can build a low pass tuning circuit. So what I do, the bottom quarter of my 80 meter loop is not too high above the ground, maybe 10 feet or so. And I just feed it with open wire. And then I use some relays in a box that I built. And I have some controller cables coming into my shack. And I can switch my antennas and the feeds for them from my shack. And I also learned how to build a low pass tuning circuit in another box. And I use that to load my wire antennas. And in this case, for 160 meters, I feed the 80 meter loop, tie the wires together as if it's vertical, and feed it against my ground radials through a low pass circuit. So the coil goes from the antenna to ground. And then I have, I think it's in parallel, 2 doorknob capacitors that are in parallel. So we can talk more about that in the form after if anybody wants to, or email me, or whatever. And my rig I'm currently using is the Allcraft K3 with a diversity receive. So that means I have the both the main receiver and the sub receiver, and it's full of crystals that I commonly use for filtering. An ACOM 2000 amp I was able to get a few years back. Very fortunate to have that. And it can run full power, full 1500 watts. And for receive, I've tried some receive antennas. I won't get much in this because I know it's going to be talked a lot more about that in the forum today, but currently my receive antenna is a high Z triangular receive array. It works good. It helps when I'm trying to work Japan or Europe. It's a big help. So the receive part of 160 meters is my biggest challenge, because I'm on a small lot. So I'll go on from there, see if it goes okay. Now, so one thing that I learned how to do, I have, let's see, 1, 2, 3. I currently have 3 wire antennas, 2 roughly 20 meter delta loops that I don't show in this picture, but they're located close by. And I have this 80 meter vertical loop. Now, if you add up all the measurements here, it comes up about, I think, it comes up a little short for 80 meter full wave. So I have a couple stubs in here. And the reason why they look like that is because when I given my whole antenna farm, when I added these stubs and changed the length a little bit, it gave me the pattern that I wanted, okay? So there's a method for the madness, but that seemed to work the best all around. And I feed it. You can see here, if you know EasyNet, the source point here is the bottom corner. And if you learn about loops, vertical loops, especially vertical loop arrays, delta loop arrays, you'll see often they're fed from the bottom corner, because when you're using it as a loop for 80 meters, it's quiet. You still get vertical polarization, but it's quiet. So anyway, back to 160, like I say, if this kind of acts like a vertical, right? So I'm going to go to the next slide, which are my EasyNet plots for this antenna. Now, this turns out, in my experimenting with EasyNet does a pretty good job predicting, how your antenna is going to act. So in this case, it does a very good job. You can see the pattern if you know patterns for antennas. It's kind of ugly, right? And with 160 meters, unless you have a lot more real estate and money than I do, your pattern might look like this, right? But this works. And I'll show you more on that in a second. But you can see here in EasyNet at 20 degrees, I'm getting about 1.2 dB gain in that direction. So you can see it's omnidirectional, all right? And I get between like 1 and 2 dB most of the way around, all right? Now I'm going to go to the next slide. I'm not going to dwell on this. Now on this slide, if you use N1MM and you use a telnet window, you can select a cluster on there that'll show spots of your signal. So I got on Saturday morning last weekend, I think it was. Oops. Hang on, let me see if I can go back. I bumped my computer and I went to the next slide. There we go. I just got on with 45 watts, just barefoot, and I called CQ a couple times, and I got these spots that came back from, skimmers or whatever. And you can see I was hitting the Western US in general, is what this tells you, to make a long story short. And then over on the right side here, I turned my amp on. I came off standby. And with 1500 watts, I was able to then reach into Vancouver, V7, and also California, right? So these spots are showing, okay, I'm getting to those places now. Now let me go ahead and jump to the next slide. This is a device called a Soda Beam Whisper Light, okay? And I got this for Christmas, a Christmas present a couple of years ago. And this is a little device. You can plug your antenna in one end and your computer in the other end. And there's a little bit of configuration software. Then there's a website you can go to. And you let this run for a couple nights on 160 meters, and you can pull down a graph like this. It's pretty cool. And what this shows you is that at 200 milliwatts, this is where I was spotted. Okay, so 200 milliwatts I hit, I got into Canada here, the West Coast, US, and also the Caribbean. All right. And obviously pretty heavy here toward the northeast, right? Because when I designed those little stubs and easy neck, obviously I was trying to get the best pattern I could to Europe. Okay. So let's go ahead and go to the next slide. And overall, like let's say I work at WW4LL. He has not much on 160 meters, just a inverted L at a much better QTH and much more real estate, much better radials. So his inverted L actually performs better than my whole rig I'm telling you about here right now. So what I have up here in my lot is just, kind of like the best thing to do in this situation. So what I'm going to do now is, pretty much completes what I wanted to say here. My last QTH, I had a horizontal 160 meter loop that went between like 50 and 70 feet high, suspended from trees. That was a fun antenna. I think I worked all the continents, if I remember correctly, with that antenna. The pattern looked awful. The antenna worked. But you need a lot of real estate and trees or something for that. And then the best antenna I've ever used is a 160 meter Foursquare. That's really something. And of course, Beverage for antennas for listening, that's something else there. So I'll go to the next slide and talk a little bit about operating my 5 minutes I have left. And here are the main things, I think. So for the contest, the free, our 160 meter band, and CW is going to be in the lower part focused. 1800, you'll hear signals 1800, 1900, which is another challenge at 160 meters because it's high Q generally, unless, like I say, you can afford a Foursquare or something. But if you can get your antenna working between 1800 and 1900 with a tuner or something, that'll be where the contacts are mainly. And keep in mind, as John Laney reminded me a few years back, Europe is 1810 and above. So keep that in mind if you're looking for Europe stations or trying to, if you can run and you're trying to have some Europe call you back. Then I put down the times for the 160 meter contest this weekend. One thing cool about 160 meters, if you work 20 meters, you can't hear local stations. Generally, it's a long distance kind of band. On 160 meters, you can hear local and long distance stations at the same time. It's pretty cool. So pretty much as it gets dark across the US, you can work that geography as it becomes night, so it's a lot of fun. I have some other notes in here. The first 2 hours. So one thing that I've learned is that the first 2 hours of the contest, in every contest I've been in, for me, the first 2 hours is the most important. If you can do well in the first 2 hours, your success rate probability goes way up, I think. So what I try to do is I've had best luck at trying to run the first 2 hours, but like during the sweepstakes, I was trying to run and not doing really well. So I thought, well, went to search and pounce and hit the malts. So I'll do search and pounce until, if I'm trying to work the stations in search and pounce and it seems to be crowded, then I think, well, if there are a lot of people calling people running, I need to go back to running. And that's pretty much how I decide and go back and forth. Obviously, if you have a Foursquare or something like that on 160 meters, you're going to spend more time running, right? And reference material. Okay, so there's a guy named John DeVoldair, who's out of ON4UN. I got to work him many times in contests 160 meters because he had quite a station over there. He has a great book called Low Band DXing. I've read about the whole thing over the years. It's about 2 inches thick, and it is the best reference I've ever seen on low band DX or low band radio, period. I highly recommend this if you don't have this book already. Another website that I've always enjoyed is WHAI. I've heard stories about WHAI. His 160-meter four squares and the experimenting in the beverage arrays. This is all on his website. It's technical, but it is really fun to read. I've read that entire website on the antennas and low band part of it, and toroids. So go to the next slide. And then what I have on this slide is just different times to reach different places. Europe, probably the best time from a small station like me is, 11 o'clock, 12 o'clock at night Eastern. If you have a better antenna, you can start working Europe as soon as it gets dark here, or, even 7, 8 at night. Sometimes I can work Europe that early if the conditions are really good. I talked about yes. Okay, Hawaii and Alaska. I've had the best luck working Hawaii. Always wake here to this QTH, 2 a.m. And Alaska, the same thing, very weak signal. Really got to listen hard and set your RF gain right. But 4 a.m. is my best chance to work in Alaska at this location. JA, about an hour before sunrise, I start looking for JA spots, start listening for JA. And usually when I hear them, it takes me half an hour to work them. It takes a lot of patience because you're fighting against the whole rest of the US and Western Canada. And they're a lot louder to Japan than we are, no matter what kind of antenna you have. But me having a small station just takes a lot of patience. You got to really listen. What really slows it down are these guys that keep calling and keep calling, then they go back and forth and keep calling. You got to listen. So I either call twice and just listen and wait for everybody else to stop calling, or if there's people stop calling, there's a little bit of break, I'll send my call again. That's okay. But then you got to listen. Listening is the key for working the DX on 160 meters. It really is. And I can't always get JA. I can't always get some of the Europe stations. The Caribbean is very workable from this QTH. And I don't have much of an antenna farm, but just the other night I worked HQ9X, who was on practicing for CQ Worldwide, and I worked him the first call. It was, it's very, very workable, the Caribbean from here, and the Caribbean's in saltwater. That's another reason why. And so I normally run unlimited with N1MM, so I make use of spotting in N1MM. And I use the band map and mulch sheet. And that is it, fellows, for my presentation. Kent and Andy.
Wow, Charlie, perfect on the dot, 15 minutes. So we're going to have more discussion afterwards, but I thought, since it's fresh in our mind, if anyone has like a quick question about the presentation, something specific they want to follow up on, we could ask it now, or of course you can save it for later as well.
Charlie, where did you get your information about the low pass filters?
Let me look up what that tools card. So if you buy an AT&T antenna book, it comes with a little CD. I think it's called TL. When
AT&T
the other people
or ARRL?
No, ARRL antenna book.
Okay.
And it comes with a little CD and it comes with software on it. One of the software, and I'll look it up while the other people are presenting.
It's all right. I've got that, but yeah.
Okay, and I'll look up the name of that software again, and I have it on my PC, but it's great. You can put in like the information from your SWR meter, and it'll give you suggestions on the tuning circuit to build.
Awesome. Any other questions? Well, my question is, so you don't sleep then? You work right through to the morning?
No, I stay up the entire night through the whole thing, both nights. And then, the downtimes during the day when it's really hard to work a station.
All right, excellent. Okay, so that's good motivation then, to remember that you won't be sleeping. If we're sleeping, then somebody else is competing.
Absolutely. Yeah, when it's dark out here, you want to try to be on the air.
Charlie, you might want to mention where the JA window is. I don't think you mentioned that.
This is from April 22nd of 2020. On 160 meters for Japan, it looks like the allocation is now includes 1800, 1810, all modes, new assignment. And I thought, yeah, I'll go check this out because I thought what you just said was right. You know,
And I believe that they can still transmit above 1900 as well, but not many do that anymore. It's mostly the lower in the frequency. And actually, I think some of the South Pacific is the same way too, that they have to be above 1900, like South Pacific and Southeast Asia.
oh,
Yeah. I know that because one year I was down here, somebody sent me an email from, I think it was from Japan, and told me that I needed to listen up
mhm.
because they heard me.
It's possible at one point in time, you know, just looking at this, maybe at one point in time they could only work 1825 and above, you know,
Yeah.
because it's kind of how they have broken down here on this ARL article I found.
Well, I know that I think they did change it 2 years ago, and now the Japanese stations can be on FT8, can be on 1840 on data, and so that makes them the Japanese stations much easier to work on the digital mode. Hey, Charlie, I don't think you're off the hook. I think we have more questions for you, but in this sort of speed format, we're going to go on to Jeff. Jeff?
Okay, first a disclaimer before we start. I am not a 160 meter receive antenna expert, and a lot of what I'm showing is just things that I've found from doing research. So keep that in mind. Just like Charlie, I've read a lot from W8JI, and I'm not going to repeat all this, but I'll keep it up here for about 30 seconds so you can see why you need a receive antenna. So, and this is being recorded, so you can reference this later. Okay. Okay, now with receive antennas, there's something called RDF, receive directivity factor. And this is something that helps you determine the performance of your receive antenna. So the higher the RDF, the better. So for an example, a lot of people use a K9AY loop. It's got a 7.7 dB RDF, okay? But if you go down the list, some people use the small, like kind of Foursquare, something like a high Z antenna. You can see you're getting probably what, 3 or 4 more dBs. And then the best are, you know, a Beverage. So the difference between, say, a single 1.75 length wavelengths Beverage and a K9AY is pretty significant. And then if you actually would phase 2 of them, something like a 2 broadside 1.7 wavelengths Beverages and a 0.7 wavelength spacing, you can see the RDF. That, I mean, that's like really, really good. Okay, we'll go to the next slide. So anyway, receive antennas can be categorized in the following categories, and if you can refer back to that list, but the small loop antennas, something like a K9AY, electrical steerable arrays might be something like a high Z or an SAL loop, or a simple one is a Beverage on the ground. And for someone that has a small lot, that's a perfect receive antenna. It's not gonna perform like a long Beverage, but it will probably work better than your transmit antenna as far as hearing people. Same with the K9AY loop. It's going to work better on receive than your transmit antenna. And then the higher performance Beverage antennas are the long Beverages that I spoke about when we were looking at the RDF chart. Okay, so here's examples of a small receiving antennas. You get 4 to 9 dB RDF, and as you can see, a bog is on there, beverage on the ground, 6 dB. K9AY is a little bit better, 8 dB. A shorter beverage, 250 to 400 feet, about 7 feet high, is probably about the same as a K9AY. And both the K9AY and the shared SAL, the shared apex loop, are pretty close together in their performance. And this is from Contest University, by the way, as you see. This is a slide from that. Then you got small loop antennas, 4 to 7 dB RDF. Examples of that are, you've probably heard of some of these, flag or a pennant or EWE, or there's a V3DO antenna is an example of a small loop of antenna, receive antenna. So here's like an example of a steerable antenna. This is what IV3 PRK uses. And as you can see, it doesn't really take a lot of space. I mean, the verticals are only 25 feet high. And you're getting 12 dB RDF on a 1/4 acre lot. So if you have the urge to try something really good, maybe something more complicated than a K9AY loop, this might be the way to go, because for the amount of space you're using here, this is really good. Let's see. Okay, here's a bog antenna. And what they are you cut it for about 225 feet, and you just lay the wire on the surface of the ground, and you get 6 dB and 90 degrees beam width. And then you can make switchable ones in different directions if you want to do that. So they're about 6. You could phase 2 together, space them with 125 foot end fire spacing, and you get what, 1 more dB, and then 2 wide space ones, you're getting about 8 dB. But it looks like you need 350 feet of broadside spacing. But if you go back here, you could do this on a 1/4 acre lot and get 12 dB RDF. So that might even be better than that. Okay. So here's an example of the feed point for a beverage on the ground. You'll need to get a transformer, and then you'll need to terminate it. And later in the presentation, I'll show an example where what you would need to buy from DX Engineering. Okay, here's high performance receive antennas. So this is if you have a lot of room to put a longer beverage up. And as you can see, the RDF on these antennas are pretty good. Let's see, I'll just go on for the interest of time. How long have I been talking? Probably about 10 minutes.
Yeah, you've been going a little under 10 minutes. So
Okay,
yeah,
all right. Okay.
about 7 more minutes.
Okay, we'll go through this quickly. There's not a lot more slides. Here's examples of small receive antennas, an EWE antenna. This is something, a pennant that they use at the WB9Z used at KP2A, and it kind of gives you an example of what you need. You need a 18-to-1 transformer on it. It shows how you feed it and everything. And the directivity on this is back toward where this feed point is. And here's another one that is pretty small, a V3DO loop that would fit on a small lot. And in interest of time, I'm going to go quickly through this, and then everybody, if they want to find out more about these, they can just go through the recording of the presentation. Okay. And this gives you an idea of what the pattern of a V3DO looks like. And it's actually pretty good. It's got, pretty low angle. I think this is about 45 degrees. So, down here is probably what, about 30 or whatever. And as you can see, it's a fairly low angle antenna. And there's a horizontal pattern of it. Okay, this is electrical steerable arrays. Here's an example of what you would need to do for a K9AY loop. And I don't know that they sell the boxes anymore for K9AY. I think they do, but I'm not 100% sure about that. I know they don't sell them at DX Engineering anymore. And this will give you an idea what the direction and the angle of a K9A loop. Again, a pretty good receive antenna for such a small antenna. Okay, here's a shared apex loop. And this antenna works really good. WW4LL has one of these, and when I operated at Fred's station, it works great for the amount of space that it takes up. And we also have one here in Bonaire that when we have more people than just John and I that we've put up, and it's an excellent receive antenna for such a small space. But the downside of it, it's pretty expensive if you buy it from Array Solutions. I think it's like about $800 or $900 or something like that. Yeah, it's pretty expensive. And here's an example of what a shared apex loop looks like. And as you can see, it doesn't really doesn't take up a lot of space. Okay, this is actually from the web page that on WX0B. They sell one that's 30 feet high on a 30-foot pole, one on 20 feet, and one on 12 foot. And this kind of gives you the dimensions of how big it would be based on the vertical mass that you have for it. And then here's what the feed point of a SAL loop looks like. I think it's expensive because of this box. It's pretty complicated what's in that box. And plus the controller as well. And with an SAL loop, with basically you have 4 wires, kind of like think of it as a delta loop, and then another delta loop 90 degrees from that. You can actually switch in 8 different directions with an SAL loop, which is pretty cool. Here's an antenna that they use at PJ2T. It's a receive only four square antenna, and that works pretty well for them. Okay. Another one, High Z, sells, this is another short vertical array. Again, I think these are pretty expensive as well, but if that's no object, something like this would probably be pretty easy to put up, because I think the verticals are like only about 20 feet high. Okay, and then you got your classic Beverage antenna, which basically it's 1 to 2 wavelengths long. One that would be 2 wavelengths would work better. And you basically, on the one end, you have a transformer. I think it's maybe about an 8-to-1 or something. And then on the other end, you terminate it with a ground stake and a 470 ohm resistor. If you can't drive a ground stake in the ground, which we can't do down here when we put up a Beverage because it's rocky, we just like kind of drive something kind of in the ground a little bit, and then we put like little maybe 30-foot radials on it, and that works pretty good. And the favorite direction would be where you're terminated here. And here are suggested lengths for beverages. This is W3LP from W3LPL. As you can see, a 160 meter beverage would be 880 feet. But you can, if you have a little bit of a lot, you can put one that's one wavelength, which is 585 feet, and that might be manageable for some people to do that, but you would have to have a pretty big lot to do 880. Here's an example of a bog in a beverage on the ground, a bog. Basically, at the one end, you got a 9-to-1 transformer, and then again, you're terminating it with about a 50 ohm resistor. Okay, so where do you get all these parts to build a receive antenna? How much time do I have?
All right, let's say you have 2 more minutes.
Okay, well, I'm doing pretty good then. I'm near the end. Okay, where you buy stuff? Okay. Okay, here's DX Engineering. Here's something, here's the transformer that you would need for a bog, $32.99, fairly cheap. And I can't, it's kind of small, but I think it says 8-to-1. And then here's another one from DX Engineering, just for a regular beverage antenna. A little more expensive. What, $63? Okay. Here, if you want to terminate, if you want to go fancy and get a terminating resistor in a box, you can get it from Unified Microsystems. Although I think DX Engineering just sells 470 ohm resistors, and it would probably be a lot cheaper just to buy that from them and make your own little box to do that. But if you don't want to do that, just want to buy everything, that this is an option. Oh yeah, here's the terminating resistors that they sell. What, $24.99? So fairly cheap, and you get quite a few of them here. And another thing you might want to have is a preamp. And KD9SV is well known for low bands, and he sells a preamp. Although, if you could find, let me go here. I've got one of these. I got one of these old Amico preamps, and these would work just fine for a preamp for 160. Another thing I do on my K3, I have this, what's called the receiver guard, because you got to remember that when you're transmitting, and if your receive antenna is close by, you could, have a problem blowing the front end of your receiver. So it's probably a good idea if you would put something like this in line, and it would protect your receiver. The type of insulators to use, I mean, they're easy to find. I took these pictures from Tractor Supply of different, insulators. You could probably just put up posts or whatever, or like at my house, I mean, I just have trees that they would just screw into a tree. Okay, and that's it. Here's some pictures from Bonaire. Here's the SAL loop that we have. Here's our European beverage, goes in this field here. And this is the hilltop we're on. And that is everything right there. I guess I did pretty good too, huh?
You did awesome, Jeff. That's a gold star for you right there.
Well, thank you so much.
Hey, we have we're going to go on to Ignacy just in a minute. If anyone has a question, we can also save it for later. But does anyone have a? I think we have time for one question.
Perhaps I just have a comment that with receive antennas, one can get easily fooled by how quiet they are. So let's say you have a loop, and the loop is very quiet, and you try a vertical, and the vertical is very noisy. But then there is a DX, and in that noise you can find a DX, and in the loop there is nothing. So anyway, I mean, one of the disadvantages of the loops is they somehow pick up high angle of radiation. You don't hear DX. And if your goal is just working in the US, it's okay. But with the US it's hard. And then I found it out with a couple of loops. I mean, there are a few loops. One loop is, let's say, you can have a tuned loop, let's say 3, 4, 5, 6 feet in diameter. So there are those concentric loops. And then also there is the amplified loops that are very popular. So anyway, they are very good because you can kind of turn them in such a way that you minimize noise from a specific direction. But for DX pickup, they are not good. So sometimes having noise is good.
Although you could probably help with that by having a preamp as well.
No, I mean, it's not a preamp. I mean, what it means is that loop has picked up high angle of radiation. So it means that closed signals could be 1,000 times stronger than weak signals. And then with a vertical, they are only 100 times stronger.
Yeah.
Anyway, so I mean, simply the low angle signals are not well readable. Of course, under good conditions, you can copy anything.
Right. And, you know, something else you could do, you could just experiment with some of your other antennas. I mean, I have a center fed SEP antenna cut for 80 meters, 130 feet long with open wire. And I've used that as a receive antenna. And sometimes it works better than you know, your transmit antenna as far as pulling the signals out. And actually one year when I was down here, we didn't have a receive antenna up, and I used our 40-meter beam, our 2-element Yaki, up 90 feet, and it worked pretty good as a receive antenna. So you just got to kind of experiment.
Yeah, so it kind of, I fooled myself that way at the beginning of my career on 160 meters. That is, I could receive it either on inverted L, it was very noisy, or on, let's say, on a dipole, some 50 feet up, kind of, it was WINN with coils. And it was very quiet, but I never had any DX on it.
Yeah.
So it was very good to pick up close signals and making lots of kind of contacts with Ohio, but far away, well, it was not good.
Yeah. I think the thing is that you just basically, you know, at your QTH, you know, wherever everyone is located, you just need to experiment and see, you know, which one works the best for you.
Awesome. All right, thank you. Well, hey, I think we are ready for Ignacio's presentation. Ignacio N09E has recently built a new station out in actually in the sort of the no man's land that is between Athens and Augusta. And he's had a lot of recent success with that. But of course, he had good luck with on 160 meters operating from his city lot in Athens as well. But I'll let him tell the story. Take it away.
Okay, well, it's all not rosy. I bought it, and well, sometimes I'm not very happy whenever there is a sewer backup or a road washes out, and then I need to pay a few $1,000, or hell comes with RFI from power lines. I mean, and that the local guys know nothing how to fix it. So it's not all rosy, but anyway. So I mean, I don't want to preach to the choir because there are quite a few guys who know what to do with antennas, and then of course there are books like ON4UN or the ARL antenna book, and they have basically all the information. So I give some kind of generalities at the beginning, and then we'll focus on my experiences. So perhaps what kind of antennas we can have? We can have dipole or inverted V, and then full size is about 260 feet. We can kind of short it with coils or traps, and there are such antennas. And then, well, it's poor DX performance if they are at a low height. Also, you can work lots of stations, especially during the contest, because contesters have low noise, excellent antennas, so they pick up QRP with a piece of wire. So I mean, it's poor DX performance, but perhaps late N4PN, if anybody remembers him, he had an inverted V at 100 feet, and actually it was working very well. It was better than my, say, inverted L at that time. slightly better, not much. So the next thing is full vertical. Few people can afford full size. Well, we can always build a capacity hat or do inverted L. Then we can use ground to elevated radials. If the antenna is too short, then we need to use a coil, if capacitor, if it's too long. And then if they're short elevated radials, then the feed is at a very high potential. We can use zillions of balloons. This won't help. We put simple transformer, it works beautifully. I give examples later. And of course, performance of vertical is soil dependent. And then a very easy choice for deployment is end-fed antennas. So, and then Wald, for example, who is here, use that one. So what's going on? There is a one box at the end, and then you have 260 feet, and you just shoot it up on the tree somewhere. I mean, whatever you can do. SWR is pretty good, and it works. It doesn't work great, but you can work stations. So this is the simplest antenna to do. So with radials, and then of course, I think many people know what to do. Well, the simplest would be if we use on ground, perhaps to put 4 74 feet radials, and then if we have 16 of them, it will be pretty good. 32 kind of 100 foot will be standard, but some guys, the top guys, use 100 feet and 100 radials, and it looks like that it helps with low angle radiation. And we can also use elevated radials, and it doesn't mean that they need to be half, let's say 1/4 wavelengths. In fact, if they are close to ground, the ground shortens them, so they are less than that for let's say for resonance. But actually, they can be any size. And then there are some theories that if you have shorter radials, they actually have less earth heating, so they work better. At my home, I have 7, let's say, 70-foot radials, and there is one contraption that is called the FCP radial, and you can see what it is. So I mean, if you have elevated radials, let's say 2, they need to be very close to size, so they both radiate the same, not just one radiates. And this is the one that radiates both sides, and then the one side is just 30 feet or 35 feet long, and then it replaces a coil. And then there are claims, you can read ARL article, that it works better than anything else. So I mean, almost better than Foursquare. You can believe it or not, but it's interesting to hear the explanations that simply shorter radials don't hit the earth too much. And then always say the elevated short radials need to be fed by transformers, because balance won't have enough capacitors. Let's say will not block the common waves. Well, my first experience with 160 meters was when I was in Champaign, Illinois, and I simply had 40-meter dipole fed by a ladder line just on top of the house. I used a tuner at 400 watts. And then in a 160-meter contest, I could work coast to coast, but I never had any DX. But it means, well, it's good enough to have fun. Anything kind of works, provided it's not coax. If it's coax, it needs to be kind of nearly resonant. Once also, I went to a mountain in Florida. Do you believe there is a mountain in Florida? I think the mountain is 300 feet high. It's in Brooksville, kind of southern Florida. And then I use simply gauge 30Y, extremely thin from window, and with K to 10 watts, I still was able to make a few QSOs. And kind of the message here is that for 160 meters, antennas need to have sufficient size. And then if you have very good size on the other, very good guys on the other end, then you can work those. Then in Athens, I had inverted L to a kind of 80 feet through, then the rest horizontal, all gauge 80 wire. And then first I tried chain link as radial, and that was terrible. And the issue is that simply the chain link with access to soil simply works as a resistor. So nearly all energy went over there. So I tried 70-foot radials and elevated them about 8 feet. Well, I have at the beginning just 2, then expanded to 7. And I did not understand what's going on. I used many balloons and all of them overheating with 400 watts. And then whatever I tried, didn't work. And there is a guy who tells you to use type 31 toroids for everything. And then I think, well, he's kind of old. He doesn't know what he's saying, because if you put in any transmit situation, all kind of nearly all energy, say the common energy, just is going to dissipate. Anyway, I made the transformer, simple wire, and then simple toroid, and there is no heating even at 1.5 kilowatts. So anyway, if your radials are elevated, not full size, one needs to use transformer. It works very well. I work 180 countries. Well, it's good enough, not great. And then I was first in Georgia in multiple contests, not really for my antennas, but perhaps for lack of competition. But anyway, it worked okay. And then I can work a number of DX, also not that much, not that many. And then this is a box from that, let's say from that Beverage, from that elevated radials, and then with inverted, very, very simple, but it survived for 20 years until the tree was cut this year. So anyway, simple solutions work. Then a few years ago, I visited the contest station Radio Lima 3 Alpha. They are about 200 kilometers from Moscow. Took lots of energy to go over there by night train. And then, well, anyway, the guys were very, welcoming. And then they have zillions of antennas. And you see that those guys have no limit to imagination. And the way it worked, first they had a station close to Moscow, but too much noise and too expensive. So one of them bought 30 acres, another 50 acres, another 50 acres, whatever it is. So they ended up with perhaps 400 acres of land over there in the middle of nowhere. And they put towers from 100 to 200 feet. And then lots of wires over there. They have 4 square 160 meters. So anyway, I thought perhaps one should just not limit the imagination. And then I found property close to rail. It was about 26 acres in the woods and looked like it was in the middle of nowhere. And my first 160 meter antenna was 140-foot wire. And I threw it to top of a pine, and the wire was just coming back. So it's kind of a U antenna. I put 420-foot elevated radials. I tuned them. It was perfect SWR. And then I don't know whether I show you about 100 kilocycle bandwidth, no capacity, no nothing. It worked, but not great. I didn't know why. I think at this time, perhaps the radials were too long. If they are too long, they are just hitting the air. So, well, the next one was, well, I put a 100-foot antenna and then loaded that tower. And then my first radials were just 16 70-foot radials. And then I did test not with WSPR because this is very slow, but with reverse beacon service network, RBN. So what I did, say I was transmitting perhaps, for a couple CQ on a frequency for a few minutes on one, not for a few minutes, just one CQ on one frequency with one antenna, then change my frequency 2 kilocycles away, and then let's say called CQ on the other antenna, and then I kind of averaged dB readings. And what was surprising that this antenna was 6 dB better. 6 dB is not little. If you run ESNAC, it would say there will be no difference, but somehow there was 6 dB difference over that. I later expanded to 32 radials, and that gave me 2 dB extra. So anyway, this is what it is. And then you see somehow see the contraption, the radial setup at the bottom for those radials. And well, and then there is shunt. It's shunt fed and needs very big capacitor, so much more work to do. And the other one, but 8 dB difference is big, so this one works pretty well. Also, I have 7 beverages from about 500 feet to 1,000 feet, and they make big difference. And then, so anyway, it works very well. So this is shunt fat tower. Perhaps I said everything what I say. And then with beverages, say I work regularly VK and JA. So let's say the antenna is competitive, but not extremely competitive. Why? Because there are lots of guys who are perhaps where the soil is better. Some of them have Foursquare, some of them are close to seawater. So I'd say it works pretty well. But anyway, I was wondering why the antenna in the tree was 8 dB worse. So I'm still not sure what it was. Well, and then I travel every Christmas to St. George Island in Florida, just south of Tallahassee. And then a question is, can I have kind of a transmit antenna for the Stu Perry contest? And then I did, and then my antenna was, say, kind of a contraption like shown here, and that is, there is a 40 feet spider pole, and then with two wires for capacity head and 2 radials. And then since the pole is not very sturdy, those extra wires were just 26 gauge. And they need to be, well, this is how it looks like. It looks pretty good. And then, well, what's the most important here is to find a house where there is no RFI. If you have RFI, you can't work anyone. In some places are very quiet, some are terrible. And then you see the setup of the spider pole is just set with tie wraps. It's a very, very good pole. I have it perhaps for 10 years or more. I tried to destroy it hundreds of times and it doesn't work. It just holds its own. You attach it to anywhere, attach wire to it. And then, I mean, it has only 4 feet length when folded. And you see my matchbox at the bottom, very simple one at the time. So a coil, and then on the left and on the right, this is a transformer. Is that transformer good enough? Well, for 100 watts, there is no heating over there at all. So I could work in contests very well if the house is, let's say, far away from the beach. I don't work DX, but where I work many, I mean, I could work 200 stations in Stu Perry. Well, and then Spider Beam has those 40 feet and 60 feet poles. I cannot recommend them more. And at one time, just to show how strong they are, I was operating from Easter Island. And then this shows that spider pole that was holding end-fed antenna, but also I set up an 10-meter beam at half size at about 20 feet, and it was great. No extra, no, let's say, any guy wires, and there was a very strong wind at that time, and nothing happened. Nothing happened. So anyway, those poles are very strong. Now I replace my, let's say, feeding places with that extra contraption. What it is that on the left side, you see a PL259 to BNC connector and BNC to, let's say, how is it called? Bind poles, I think. Then you see a transformer, and the wires are from the Ethernet wire. And then on the right, there is a coil. And the coil, and then what's very important is that the balloon is made of ferrite. And then the coil is made of on iron core. How many turns? I kind of do experimentally and check with the SWR meter, and it shows me what it is. How good is it? I try to run 500 watts with it, and then it's slightly heating, but it works. So anyway, that's my kind of a portable setup device for 160 meters. And at one time, say, one problem with those houses on St. George Island was that simply there is too much noise in very few places. Say the noise is overwhelming. There are bridges where you could put antennas, but with high power lines, you can't hear anything. But the island has a campground here in the middle of nowhere. You can go there by boat only, or perhaps by having something on a cart and traveling for a few miles. So one time I tried to set my antennas over there. And then if you have something close to salt line, you see that at low angles, you may have advantage of perhaps 15, 20 dB. It's a big thing. So anyway, well, this was my inverted L over there. And then strangely enough, as I set it, it has nearly perfect SWR with resonance at 130. And then what's the property over them? Simply you would not believe that is 2 hours before the sunset, you hear strong Europeans. And why? It's extremely low angles, and you can work anything you want. And I think I made 250 QSOs. I could have done more, but somehow I was in a tent. Well, let's say you see the radial, just one radial more than that was not necessary. But it was very cold at night, and I didn't quite set the, let's say, N1MM with cut to reduce power use. And then in the end, say, the operation was kind of difficult, and I was very cold at night. But anyway, it's an unbelievable thing. And then at one time I worked a station that K4 BAI close could not work with 1.5 kilowatts. So just the effect of salt water. Well, later on, I tried to rent a house close to, say, with some walk-in to the, to salt water. So I put my, let's say this is 40 feet spider pole. I made it as into inverted L, and there was just one radial on the deck. And then it worked very well for 100 watts, and I had an expert amplifier to work with a kilowatt, whereas kilowatt, something was going wrong. And what turned out is that the radial wire on the deck was sparking to some metal. I found it after the contest. So anyway, something like that. But if you have an opportunity to do it, you will do better than any station on land. And I also did it another time, but at that time I didn't have access to, to that place from my house. It was too far away. And then it's inverted L with a balloon over there. And the balloon just blows it, so it becomes that wire here is kind of horizontal. And it works very well to a degree, but it was raining, so I could work only so much under some cover, and then had enough. But for DX, it worked very, very well. Well, also, so there was a mention of the ON4UN book. This is ON4UN. I had a conference close to his town and visited him the year he later died. Well, he's kind of old, but anyway, he made tremendous contributions to 160 meters. And I think this is my story.
Ignacy, thank you so much for a fascinating presentation. Any questions?
This is Charlie. I have one, I guess. So Ignacy, where do you buy? It looked like you had a very large capacitor for your shunt fed tower. Where did you find a capacitor that big?
Yeah, that's a good question. So actually, I tried first a button capacitor, and then it would burn, and then well, the air capacitor was good, but it didn't have enough capacitance because I needed 350. My vacuum capacitor that also had too little capacitance. So I bought a button one that is perhaps 2 inches wide, and that did the trick. I think one could have done it the other way. One could have made the the shunt, let's say, wire thicker and also make more spacing. So in that case, the capacitance rises and then there is less voltage over there.
Okay, that's, and in fact, what I use with my antenna with 4 power is a pair of those about 2-inch doorknob capacitors in parallel to handle the power. And I can hold down the key for 2 minutes, go out and feel it, it's cold. Yeah, so
if it doesn't spark, if it doesn't spark, doesn't cause trouble, it's good enough.
Yeah, those capacitors are hard to find.
Yeah, Ignacy, on your inverted L antenna, are you at the feed point? What are you using an unknown there, or what are you using there?
Well, this is the point. So let's say that you create an inverted L antenna, and the question is, what do you with radials? So I mean, the simplest way is to put them on the ground. But I mean, for good ground, perhaps you need at least 10, 70-foot radials. You can get by with less, but anyway, that's kind of a standard. But another possibility is to use elevated radials, and then perhaps you can use 2. By salt water, 1 is enough, and 2 will not give you anything extra. But in normal circumstances, 2 elevated is pretty good. And then if you put them full length, that will be about 120 feet, they will hit the earth. So anyway, you need to put short, and then having at that time, the feet is a very high potential. So if you try to have a balloon, the balloon will be extremely, I mean, you need 5 balloons in a row and it will still hit. So you can use a transformer, and there is a good side to a transformer is that if your SWR is not close to 101, then first you can ignore it and just use your tuner. Or if you don't want to ignore, you can add 1 extra turn or take 1 turn away just for the right impedance so that SWR is 1-to-1. But if they're short radials, you need a transformer.
Okay. I actually have full-size 130-foot elevated radials on my inverted L. It's I've got like a 2-acre lot and woods in the back, and they're held up by the trees. They're probably, I don't know, maybe 8 feet off the ground, each of them. So it actually works pretty good for me.
Well, I mean, it all depends. It's relative. Can you compare it to anything? And then ON4UN book says that elevated radials are not as good as on ground radials for 160 meters. And then average experiences of those who tried show about 4-5 dB difference. And then it could be that simply the radials should not be 1/4 wave. 1/4 wave is a kind of a very special number because it guarantees you low impedance of the radials, but it also could guarantee poor performance. So anyway, I'm not quite sure on that. I just suspect. And then there is that famous FCP radial. And again, please read QST to say what it did. And it says that even so it just 10 meter radius, it outperforms much longer radials because simply the longer radials just hit the ground.
For what it's worth, when I was in Texas, I had really good luck. You know, consider it was still a poor antenna with just an inverted L in trees and using the folded counterpoints.
Yeah, that's
that
the one.
made a substantial difference in the RBN hits. I mean, several dB, and I actually worked even a few Caribbean DX from deep in the heart of Texas with 500 watts in that thing.
I had an experience in the ARL CW a few years ago. 160 meters was pretty good. I started out doing 40 meter single band and it got kind of boring. So, you know, I started going to 80 and then I went to 160, and all the Europeans were really, really loud. And so I found a clear frequency and called CQ, and I worked like about 150 Europeans CQing on 160. I had never had that ever happen anywhere before. I mean, even at the big stations that I operated at, I mean, just for that to happen at home with a simple inverted L was unbelievable.
Yeah, well, I mean, first it could be good conditions at that time.
Yeah, I think it was.
Perhaps your setup was working pretty well.
Yeah, I'll never forget that.
Now, Ignacy, what do you think in terms of your success with sort of competing with folks in the in the Northeast and in Ohio? Like, what are sort of the relative strengths and weaknesses sort of this general location in Georgia?
There is no chance. I mean, perhaps you can read at WAJI site how he was trying to compete with the northern stations in contesting, and I think the late W4AN won a contest, and then, but that's because they have phased beverages, so could hear more, and then of course the antennas at WAJI site are pretty good. I encourage you to visit his site. He must be pretty old at this time, but it's good to see from a distance, and I'm sure he would welcome visitors. So, and then we also know the story of NQ4I, who folded his contest antenna, and then you cannot compete with the Northeast on that equal footing.
Hey, Andy, I can tell you just from being from Ohio, the Georgia has clay soil, which is not very good conductor, but Ohio and up along the East Coast is all farmland. That's the big difference. And if you get over by the ocean, that's even more of a big difference. So I would imagine if you lived in Georgia and you lived on the coast, you'd probably do pretty good, but inland, because it's clay soil, probably not.
So I kind of felt, I'm wondering whether to go one time to St. George Island, because it has that, I mean, the north side just has opening, say, to Europe, and then between the island and the land, there is perhaps 2 miles, so it's a couple of wavelengths. So actually, I mean, it's excellent pickup, but you need to have power. And at that time, I didn't need any beverage. So it would be good to go and try it. And then perhaps the results could be spectacular. Last time, again, I didn't figure out that there was something with radial. And also I had very bad luck with the MFJ coax that by MNP, what is it, this? The Italian made. It had a bad intermittent conductor, connector. It's a connector that's supposed to be better than anything. And it took me a few hours to identify it, and it could have been time just to find out that the radial touching the deck was actually sparking, and then a kilowatt or 100 watts make a difference.
Yeah, I've been to St. George Island before and operated the IOTA contest just using mobile antennas from the car. And it's just unbelievable what saltwater does, as far as people hearing you. And same on St. Simon's and Jekyll Island. I've gone over there as well. And like in the IOTA contest, I mean, using Hustler mobile whips on 20 and 40 meters, I'd have a pile up of Europeans on me. So I think it would actually be fun to go over there and do a 160 contest to see how, you could do. I bet it would be pretty good.
I mean, the problem with 160-meter contests is that they are in the winter time. So the northern place is not very good to camp. And even St. George could be not good. And then I imagine at night it's 40 degrees. 40 degrees when you are walking is very nice. But when you do nothing for 2 hours and with 40 degrees, unless you have excellent clothes, you feel cold.
Yes. But it's still better in Georgia than Ohio.
And no question about that. Then, I mean, again, it's excellent lookout to the north, and they have that wild, not open, but primitive campground. Primitive campground is that there are no power lines within a couple of miles.
Yeah.
It means it's crystal clear.
We have a few more minutes. We're kind of running towards 9 o'clock, but are there other questions for any of our three presenters?
I have a question or maybe a comment. I really enjoyed Ignacio's presentation. The other Steve on here, I thought him and I were the only ones courageous enough to take 160 portable, and just amazing what you've done with some of your 160 operations. And we go portable all the time with some of the contests, and of course you have to sometimes with 160 if you want to put up a big antenna. You know, we experiment every year with something different, but we've kind of settled on last couple of years like a 160 full wave loop at about 55 foot. What's your opinion of that antenna?
Well, I think it's low antennas, and then let's say horizontal have very high angle of radiations, which means that in a contest you will work lots of US stations, but you have trouble working DX.
Okay.
So, I mean, it's still fun. I mean, because it's important is to make contacts, and then in contests, I mean, the contesting stations have amazing facilities. They can hear anyone, so why not try it? But I mean, you kind of find out how good are you if there is any pileup, smaller or bigger pileup, and then you find out where they are competitive. And then perhaps for strong guys, it doesn't matter, because when you call when 100 people are calling, you are in a tough spot. But if you are, say, you don't sleep and wait until nobody is calling, you are doing well.
Well, I really enjoyed it.
Any other questions or comments or additions? Well, look, we're running towards 9 o'clock, and I mean, this has been absolutely riveting. The amount of knowledge that was packed and wisdom and experience that was packed into the last 90 minutes is really, really stunning. So if we could all give our presenters, Charlie, Ignacio, and Jeff, a round of applause. All right, thank you so much for the for making the time and for preparing these presentations.